Hey guys, go ahead and pause the video. That way you can get the notes outlined, and when you're ready, just catch up with me. Make sure that you are using graph paper to take these notes today, or else your notes are going to get really messy. Alrighty, so when we start to look at graphing quadratics, there are a couple things that we need to think about. But first, let's just look at what's a normal quadratic. And what I mean by normal is, let's look at its parent function. A quadratic that's had nothing added, nothing taken away, not been multiplied by anything, just a regular x squared, okay? So if we look at the function f of x equals x squared, I'm just going to treat this like you guys have seen before. So we're going to set up a little table, and from here, we'll plot our points. So when we're picking values, let's just start off with a couple negatives, so like -2, -1, 0, because that's always easy to plug in, 1, and 2. Okay, so when I plug in -2, I'm replacing x with -2. So what's -2 squared? So -2 times -2, 4. -1 squared, 1, 0 squared, 0, 1, and 4. All right. Now that I have some points, I'm going to go ahead and graph my function. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 3, 4. All right. And I'm going to attempt, because I know that this is a quadratic, which means it's a parabola, I'm going to really try and make this look like a U and not a V. Close enough. Okay. So let's go over some things that we've already talked about. Properties of quadratics, properties of parabolas. So I know that this is nice and symmetrical. So I have an axis of symmetry, and my axis of symmetry just happens to be the y-axis this time. So my axis of symmetry is x equals 0. My A term is 1. So that's what, when I refer to something as comparing it to the normal quadratic, this is what I'm talking about. Because our other quadratics, we're going to see some that shift left, right, up, down. Maybe they're vertically stretched or vertically compressed, which just means they get skinnier or wider. That A term has a lot to do with it, as well as our B and our C terms. Okay? So when we go to graph them, we really have to pay attention to what form are we given. Okay, because that helps us approach how to solve it, how to graph it. So if we're given something in standard form, there's two options. We can use that opposite of b over 2a to find the x value, or we can convert to vertex form and graph that way. So we're going to check out both and see which one you like best. So here's the steps if you want to go ahead and copy those down. Work with me, computer. There it goes. Okay, so we're given -2x squared plus 12x minus 17. So the first one we're going to work through a couple times is using that little formula to find the x of our vertex. Because no matter what, when you're graphing parabolas, your vertex is always key. That's always the main starting point. So let's say we got x equals, so opposite of b over 2a. So opposite of b gives me -12 over 2 times -2. All right, so -12 divided by -4 gives us a +3. All right, so our x value of the vertex, +3. So we're halfway there. Now all we have to do is find the y. So to find our y, we are just going to replace all of our x values with 3, because we want to know what's the y value. Well, when x equals 3. So -2 times 3 squared, which is 9, and then I got plus 12 times 3, so plus 36, and minus 17. So -2 times 9, so I've got -18. plus 36 minus 17. Well, I know negative 18 and 36, that takes away 18, so I'm left with 18. And 18 minus 17 gives me 1. All right, awesome. So I have, let me see if I can move that down. Whoa. All right, I guess not. Okay, that was way more difficult than I thought it was going to be. Okay, so I have my vertex at 3, 1. So when I go to plot 3, 1, 3, 1, beautiful. So again, what cuts through our vertex? Our nice little axis of symmetry. And I'm going to use that. So if I can find a couple points on one side of the graph, I can reflect them across my line of symmetry to get my other half. And that's what we're really going to do. To get a couple more points, it's all about this leading term, that negative 2x squared. So really, I'm doing it in my mind, but I'm really setting up a little table. So if I were to move, always put your cursor or your pencil on your vertex. So from my vertex, if I move over 1, well, I'm moving over 1 x units. So I'm plugging in 1 for x. So to the leading term. So 1 squared gives me 1. 1 times negative 2, negative 2. So I'm just plugging into that first term. Now if I go back to my vertex, let's say I want more than, and I can reflect it. Let's say I want more than just these 3 points. So I'm going to go back here and I'm going to do it again. So putting my pencil back on my vertex, if I were to go over 2, I'm going to plug that in. 2 squared is 4. 4 times negative 2 tells me to go down 8. All right, and once I have that, I'm going to reflect it. And I'm going to attempt to make this look like a U and not a V. It's quite the challenge. All right. So that's it. Find that vertex, and then you can use that leading term to go ahead and plot your graph. All right, let's try another one. So we have 3x squared minus 12. What is missing here? Because that looks different than our last one. Yeah, it's in standard form, but something's definitely, I'm missing the b term. So since I'm missing a term, I'm going to go ahead and rewrite this. And since I'm missing a b term, I'm going to write plus 0x because I don't have any x's, but I don't want to mess up when I plug stuff into my formulas. So when I go to do x equals opposite of b over 2a, well, what's b? Again, 0. So negative 0, all right, whatever, divided by 2 times a, which is 3. So negative 0 divided by 6, we're just left with 0. Okay, no big deal. So x is 0. Now let's find y. So y equals, so I'm going to replace all of my x's with zeros. And I guess I'll just keep it. So plus what, 0 times 0? All right, that's weird, but it works. And then minus 12. So 0 squared, 0. 3 times 0, still 0. 0 plus 0, still 0. Minus 12. All right, so y equals negative 12. So my vertex gives me 0, negative 12. All right, I definitely don't want to use 12 lines in my graph, considering I don't have that. So I'm going to go ahead and count by 2's. So 2, 4, 6, 8, 10, 0, negative 12. All right, let's look at A, because remember, A always tells us the direction. So am I going up or down? All right, A is positive, so I'm smiling. Thank goodness, or else I was not going to have enough room. So I'm going to go ahead and draw in my axis of symmetry, just so I can find one half of the graph and then go ahead and reflect it. All right, so looking at my leading term, my term that's out front, that 3x squared, that's what I'm using. So if I go from my vertex, if I go over 1, doesn't matter which direction because I'm only moving one x value, I'm plugging it in. So 1 squared gives me 1, 1 times 3 gives me 3. Now again, we numbered by 2s, so 2, 3. I'm going to number my x-axis by 1s just to make it easy on myself. Okay, so I'm going to go back to my vertex, and I'm just going to find one more point. So again, moving over 2, so plug it in. 2 squared, 4, 4 times 3, positive 12. So I'm all the way back up at my x-axis. So here's 1. Oh, that was pretty good. So I'm going to reflect my points. And here's my other half. Beautiful. All right. Hopefully you're okay, but if you have any questions, feel free to ask. I know Miss Edie's walking around and eager to help. I'm going to go ahead and pause the video, so I want you to pause it and try the next problem on your own. Try to graph that 1/2 x squared plus 4x plus 12. Try that on your own, and when you're ready, unpause the video and check your work. All right, so hopefully when you come to check your graph, you definitely notice some differences between this graph and the 3x squared minus 12 graph that we did before. Notice how much wider our graph is. Well, that's all with that A term. So remember, A not only tells us the direction, whether we're smiling or frowning, but it also tells us the width, whether we have a wider parabola or a narrower parabola. Okay, so go ahead, take a break, start working, see if you like this method, and if not, then we're going to come back tomorrow and you're going to practice more with graphing with vertex form, see if you like that any better.